Thanks for joining us once again. I'm Sammy K. Powers, and this is the PHP Roundtable. This is a live podcast of developers discussing topics that PHP nerds care about. And the ultimate goal of this podcast is to learn a little something from each other. If you're listening live and want to be a part of this little show, send a tweet to PHP Roundtable or ping me, Sammy K. Actually, just send it to PHP Roundtable because that's the one I'm monitoring right now, with a question or a comment, and we'll try to get you on the show if we can. If you've ever had strange upside-down question marks or weird rectangles showing up in your database or in your web app, and you didn't know why, this episode is for you. Those bizarre characters are called mojibake, and they rear their ugly heads when we don't really account for a consistent character encoding or character mapping. Today we discuss what character encoding is and how to accommodate for it in HTML, PHP, and whatever your persistent layer is, your database, and how we can ensure that we'll never encounter those unexpected alien characters in your web apps again. Now that we know what we're talking about, let's meet our panel. We got two guys here that are going to help us wrap our heads around this character encoding thing. In no particular order, as always, we got Andreas Heigl. He's the user group guy, and that's just what I think of when I think of Andreas. The user group guy. He's a co-organizer of Frankfurt PHP UG and runs the PHP.UG thingy. Welcome, Andreas.
Hi, everyone.
And finally, we have Everett Pott, who is a former PHP Roundtabler, and he's a PHP programmer for over 10 years and former PHP Fig member. Welcome, Everett.
Hey, how's it going?
Doing well. Thanks for coming on, guys. Helping us trying to wrap our head around this thing. Before we get into too many details and nitty-gritty maths and things, which is the British way of saying it, why are we even talking about character encoding? Why is it important, just in general, for developers to even care about character encoding?
Well, I think a big reason to talk about is because a lot of people are still getting it wrong, and I think I see a lot of PHP applications that when they first start off, it's not really something people think about. And then after a while, errors start cropping up related to character encoding, and sometimes it's already too late, and then you already have lots of bad data in your database, or maybe even security bugs and stuff. Yeah, I think it's a big source of confusion for a lot of programmers, because I think when you first start working with strings, and especially in PHP this is the case, things just seem so simple, and especially if you're coming from an English-speaking language or a country that mainly uses the alphabet without too many crazy characters. Then it's something you can just start off with. You don't really have to think about, but then suddenly all these edge cases come along because you get people from other countries on your website, or somebody who wants to use a poo emoji or something like that, and it tends to drop a little bit of a bomb in a lot of these applications. That's funny.
If you're in your car, you can't see. I'm holding up the poop emoji pillow. So this is. This requires a code point to make in your scripts. So, Andreas, you actually mentioned that since you speak German, you're dealing with umlauts over the U, right? And some maybe the S-set, which is the double S character in German. So those sometimes end up as being translated incorrectly, right? Or encoded incorrectly in a database, and ends up being something else, right?
Yeah, definitely. So for us, it's always been messy, because a lot of websites use ASCII as character set, and we're just lost with our umlauts or SZ. Stuff like forms where you put in your name and you have an umlaut in your name, and you suddenly get said, no, that's not a valid character. Is Well, it's daily basis for us, more or less.
Well, that's got to be annoying when you have
yes,
a special.
It is.
I see tweets from Samantha Quinones from the PHP Fig. She's one of the Fig secretaries, and she has an Inya in her last name, so she's always dealing with that exact same problem. So as developers, we need to code our app so that we can not give this annoying error to people with just something that's not A through Z, or has a modification on one of those characters. And before we get into details about that, I guess you guys mentioned that, like, yeah, on Stack Overflow, there's tons of questions that stem from just not understanding encoding. Like, what are some maybe typical downfalls that you see for people who aren't understanding encoding?
I think personally, like, this is a comment that came from me. I browse Stack Overflow quite often if I'm, have a little, if I have 5 minutes somewhere, I just take a look sometimes at the PHP questions and try to answer a few. But I think the biggest thing I see with the Stack Overflow questions is, it might be something like, I'm storing this in my database, but then I'm trying to output it again, and it looks completely different. It has all the, what's you call it again? Mobaki or something like that.
Yeah.
So the weird characters, the question marks, and all that stuff. And usually it means because this is because they stored something as UTF-8, but then trying to output it as Latin 1 or something like that. But I think that the underlying problem here is almost always that there's no understanding of what encoding is, how it actually works on the wire. There's only the people just tend to think, okay, I have this problem. All I need to do is throw the UTF-8 encode function on it, and maybe twice, and then suddenly it works okay again. But I think that's really it. There's missing a deeper understanding of how this actually works on a lower level, and I think it's so important for any programmer to know.
Especially, I think, when you're using MySQL as a backend, where you have to be very careful what part of the server, client, or connection works with what encoding, and you can get a lot of mess out of that.
Yeah. Yeah, and there's a guy called Joel Spolsky. He's a very famous programmer. He also, on his blog, he has an article titled let's see if I can find it. It's the absolute minimum every software developer absolutely, positively must know about Unicode and character sets. No excuses. So he wrote this article in 2003, which is 13 years ago, and I think I think people are still constantly discovering how is this supposed to work. And frankly, I think PHP is a big factor in that, because a lot of more modern programming languages define their strings as being Unicode, being a list of code points, whereas PHP is a list of bytes, and that's kind of throwing a wrench into a lot of things. Because a list of bytes might mean a lot of things, right? It might mean that you can read a binary file on your disk, and you can read it into a PHP string, and it's a valid PHP string, but likely it's not a valid Unicode string. And if you work with a language that actually has support for Unicode, like deep in its core, you would immediately get an error, because you wouldn't be able to load in a binary data into something that represents a Unicode string or a list of code points. Yeah.
Right. So in order to really wrap our hand around this stuff, I feel like there's a lot of terminology and understandings of some math and some things like that in order to really understand it. And I'm going to attempt, crossing our fingers, to maybe give a TLDR of understanding binary hexadecimal number systems. And if this is just kind of all just not making sense because maybe you're listening in your car and it requires a lot of concentration, because this, like Everett pointed out before we even started this thing, it really makes more sense to use like pie charts, or not charts, but like just diagrams and things like that where you can really kind of see it visually to understand this. But there's a great Khan Academy set, what do you call it, a series on binary and hexadecimal number systems, and that's exactly what it's called, binary and hexadecimal number systems. It's a set of videos that kind of show you what it's like dealing with base 2, dealing with base 16, dealing with base 8 and base 10, and kind of converting between different bases. So here we go. I'm going to try to do this, guys, and you can chime in whenever you want when I'm going to screw this up, but I'm going to see how quickly and succinctly I can kind of summarize this. So we have this thing that there's these terms that you might have remembered from math class from back in the day, maybe algebra or something. If you've ever heard of, I don't know if I'm saying this right, the radix or base or radix, base, something like that. I'm going to say base because that's kind of what we're using in computational terms. It's basically the number of unique digits we use to represent a numeral system. So in English we use 10, base 10, because we have 0 through 9. Those are 10 unique digits to represent our numeral system. Now, you may have heard that computers don't use base 10 at the very core level. They use something called binary or base 2. They're only using 1s and 0s to represent their numeral system. Now, as I was a linguistics major in college, and we studied other languages that had other bases. So we just studied languages that had base 5, and you're like, well, where's base 5 come from? Well, you have 5 fingers, so it's easy to count on one hand. Base 10, well, you have 2 hands, so 5 plus 5 is 10, so you got base 10. There was also these languages that were base 20. That's really complicated. You're like 20, oh yeah, toes. You can count your toes too. But there's these really peculiar languages that had base 12, and you're like, 12? What do I have 12 of on my body that I could count? Well, it's actually your knuckles that you can point to with your thumb. So if you think about your thumb on your right hand or your left hand, whichever one you're more comfortable with, is your pointer, and you're pointing at your index finger, and you point at each knuckle, you can go 1, 2, 3, then you move to your middle finger, 4, 5, 6, then you move to your ring finger, 7, 8, 9, then move to your pinky, 10, 11, 12. You got 12 places to count, and then therefore you have 12 unique digits to represent your numeral system. That's kind of interesting fun fact, which kind of translates into how we think about our number systems. So if we're converting from base 10 into base 2, we're converting from our base 10 language into binary. And we can actually convert from base 2 to base 16, and we're going from binary to hexadecimal. So some of the more common things that we see in computational stuff is base 2, which is binary, base 16, hexadecimal, and base 64, which some of you guys might be using to encrypt your data. It's not encryption, it's encoding, and it's easy to switch out of both of these. So I don't know if you guys ever did this when you were starting out programming, thinking that base 64 encoding was encryption. Did either of you fall for that one?
No, actually not.
Might be a long time ago.
Okay, I might be the only one then, but I definitely was using base 64 encode and base 64 decode to think I was decrypting and encrypting my data. But don't get encryption and encoding confused, because they're totally different things. So really quick, okay, let's just do a quick math equation. Base 10. If you think about the number, I'm going to look at this so I don't screw this up. The number 217. So visualize that in your mind. You've got 217. Now let's go from right to left. The ones place has a 7 in it. That means you have 7 ones in this thing. So you multiply 7 times 1, you get 7. Okay, great. Hold that in the bank. Now let's scoot over one more number, and we have the tens place. It's got a 1 there. So we do 1 times 10, which equals 10. All right, put that in your bank. Now, one more place. We move over one more place, and we have a 2 in the hundreds place. So we need to do 2 sets of 100, so 2 times 10, and now we have 200. Now let's add all those up. We had a 7 plus 10 plus 200, 217. This is the total. So that makes sense. That's kind of intuitive. Like, okay, base 10, that's what we think in all the time. Now, what if we had the hexadecimal representation, base 16, and the number was actually 2A? So, okay, how do you convert 2A to base 10? Well, hexadecimal uses 16 unique characters to represent the number system. So the way you can think of it is it's 0 through 9. So we got 10. There's 10 digits there. But how do you represent 10? Well, you start going into characters. So you can use A. So A equals 10, B equals 11, C equals 12, all the way up to F, which represents 16.
15.
Yeah, 15. Yes, since we started at 0. Thank you. This is why I have you guys in here to help me figure this out here. So it's base 16 because we have 0 through 15, which is a total of 16. So real quick, let's decode or let's re-encode 2A into base 10. Like, what does that represent as a number? So we take the ones place, which is A, which A equals 10, and we have one of them, so we have 10. So we're going to put that in our bank. Now we go over to what we would have normally thought of as the tens place, but since we're in base 16, it's actually the 16th place. All right, so we have the number 2, and we have 2 times 16, which is 32. You add up 10 and 32, you get the answer to the entire universe, 42. So if that was just kind of like mind-blowing and over your head kind of stuff, it makes a lot more sense to just go to Khan Academy and check out binary and hexadecimal number systems, and they really explain it really well. It's kind of lined out, talking about orders of magnitude and all these kinds of keywords that you'll need to really go deeper with all this stuff. But if you think about where you've encountered hex before, you might have noticed, like in CSS selector, like when you're trying to do like a color, like CSS color, and then you've got like these characters and numbers. That's hexadecimal. You have 0 through 9 and A through F. Also, dealing with if you ever deal with MD5 hashes for not password hashing, but other things that you might do with MD5, which MD5. Just try not to use MD5. But if you've used MD5, you'll notice that it actually represents its hash using 0 through 9 and A through F, and that's also represented as hex. Can you guys think of any other representations of hex that you would see commonly in the computer world?
Obviously, also, I guess, back to the context of our conversation, whenever you want to easily encode a special Unicode character, something that's outside of the ASCII range, and you need to put it in the context where your only ASCII is allowed, then often hexadecimals are also used. So you might see this in URLs when percent encoding is used, or you might see it in JavaScript strings when you want to stick to ASCII for your actual file format, but you do want to encode special characters, you can use that. And I guess that's also true now for PHP 7. We can also embed Unicode characters in the same way with the \u and then a code point.
And it's more or less also used when you are looking at the raw content of emails with an attachment. That's the attachments are base 64 encoded. But the base 64 is nothing else than using a hex encoding or trying to hex encode binary data.
Base 64 actually uses the whole alphabet. And
yes. But because in email you only can use 7-bit characters, so you can't use the complete ASCII, the complete hexadecimal range. But binary data is completely hexadecimal, so this information has to be encoded in a way that you can transfer it via 7-bit encoding. So that's what the base 64 then does.
Yeah, so base 64 is another great example of using a different type of base system. You've got 0 through 9, lowercase a through f, capital A through f, and then what is it? A dash and is it a forward slash or a backslash?
That's a good question.
The dash, the slash, and the plus.
Yeah, and then a spacer using the equal sign. So it's got a couple of extra characters in there. But yeah, you're exactly right. I even totally forgot about that. So if you've ever tried to look at a binary file with like a text editor and it's just got like gobbledygook all over the place, all kinds of crazy characters, one way you can look at it in a way that just looks more uniform is you could encode it with base 64, and then suddenly you get like a lot more familiar characters looking there. And like you said, Andreas, that would be a way that you can send binary files over email or like whatever. If you have a limited, what did you say that it was 7 bits?
7-bit, yeah.
Yeah, like a 7-bit system.
ASCII.
Yeah. Oh yeah, ASCII. So that's I remember that ASCII and EBCDIC were the two big kind of things that I was learning about when I didn't know what they meant. But when I was using QBasic, I remember having to deal with ASCII and EBCDIC, and it was like, oh, this is not EBCDIC, it's incompatible, or this is not ASCII. So that was kind of confusing when you were, just starting out. Like what do those things mean? But I guess before we got like really, really nerdy and hardcore on the math and everything there. If we step back and just think, okay, what is character encoding in terms of the terms we'll see a lot, like character maps and code points and things like that? Can you guys help us understand kind of like what code points are and how they relate to character maps?
Well, the code point is, if you say so, the character we know, we write, we read, and the encoding is how the computer writes down or handles this code point we know internally. So it's a way of translating the letter A we know into a computer manageable string or manageable entity. And you can in history it was used ASCII, which is a 7-bit encoding. So you just have a limited space for code points. So it's just the numbers 0 to 9, letters A to Z in lowercase, and in uppercase some special characters, some very strange and esoteric special points that are handling printer carriage return and line feed and stuff like that, or the bell character. And well, then as time evolved and people got to notice that there is not only A to Z, but also perhaps some umlauts or SZ. They were looking how can we handle that, and thought, well, oh, great, there is only 7 bits, so just use the 8-bit, and we get a completely new 128 character points we can use, which was great. But 128 characters is not enough in the end to handle all the missing characters, like the umlauts or the tilde characters from the French or the Greek alphabet or the whatever else alphabet there is.
Yeah. Actually, the history of character sets goes all the way back to the telegram, back in the U.S. back when the railroad system was built there. As the railroads were being built, they were also setting up all the telegram poles, and the different on both sides of the telegram, there needed to be an agreement around what combination of like presses and non-presses means a certain letter. And it's interesting that actually some of the decisions that were made all the way back then still have influence on how our current character set looks today. But yeah, really, like you said, what it comes down to, a character set is kind of deciding, for instance, with ASCII, it means that we decide together that we consider byte with a value of 65 is the letter A. That's really a character set. It doesn't necessarily describe how it looks like. Fonts do that and stuff, but really it's a common agreement. We all agree that 65 will be A from this point forward, and yeah, that's more or less how that works, I guess. And then, as you said, like that wasn't enough. It only worked well for English-speaking countries. So everybody wanted their own stuff in there, and so I remember back in the day when I was using my MS-DOS computer, I had an old IBM 386. It barely ran Windows 3.0. It had 2 megabytes of memory, and there we did have more than ASCII. We actually, like you said too, is like we had an extended character set, but you kind of had to decide which one am I going to use. So in my case, I'm from the Netherlands, so I chose the Dutch one, which gave a few extra characters that are relevant to Dutch. It's probably somewhat similar to the German one, I guess, with a few differences.
Yeah, I think so.
Yeah. But then, if you save, we give a new meaning to byte number 160 or something like that, and now I'm, writing a file, writing a Word document or whatever. I'm putting it on a floppy. I'm sending it to you via snail mail, and then you open it. It might look like something else because you actually, on your computer, you chose the German character set, and that gives a different meaning to the same byte. Yeah, and that's really what it is. Is like we commonly decide, byte number 65 is A, and byte number whatever might mean something in a different. Sorry, every byte has its own meaning. But then Unicode, I guess, came along, which is supposed to fix that problem because 1 byte is not enough to hold the world's characters. So Unicode came along and tried to come up with a different way of representing every character that the world might possibly have, including the poo character that we all know and love. It's just so important.
Yeah, for sure. And so really what you're saying is, as I'm typing like an email or a text document or whatever, every time I click a letter, the computer is actually storing that as a code point, which is actually just a number, right?
Yeah.
Yeah.
Yeah,
So and depending on which character map you're using, it will show potentially a different character, and that's probably why when we have some of these, when we use a database and we have all these characters that are common to English speakers, and suddenly we encounter one of these. What is it called again? The Mojibake, one of those weird characters. It's trying to translate, or I should say, it's trying to encode that code point using the wrong the character map. So, for example, maybe he wrote it originally in with ASCII, and the ASCII character for, I don't know, like you said, 64 or something like that. I think that's actually pretty common across all the character maps. But if you start going outside of sort of A through Z, both lowercase and capital letters, it starts getting into the hairy area. And each character. So real quick, the character maps. I was just looking on Wikipedia for some of the most common ones. You might have heard of the ISO ones, the International Standard Organization ones. So you've got a bunch of those, like 8859-1, which is Western Europe, or 8859-5, which is the Cyrillic alphabet, or all these different ones. And then you have then Windows has their own character maps. And so this is like crazy confusing. What's the right answer? What do we do these days?
Well, yeah, in the past, yeah, exactly. Yeah, and in the past, I think a lot of the defaults for a lot of computers were to use one of those ISO numbers. So, ISO, I think 8859-1 is the European character set, and later on became -15 when I wanted to add the euro. So that was a standard choice for a lot of operating systems, and the Windows character sets you mentioned are actually compatible with that, but they add a few more characters on top of that. But that made a lot of sense because for all those character sets, they only use 1 byte per character, and that's a very efficient way to just send information across. And because as soon as you deal with characters beyond that, then you need to 1 byte is no longer enough to store all the information, because a byte is 256 different options. So that also means that at most you will have that many possible characters. So yeah, the right choice now is to, whenever you do something, do it in the Unicode, and preferably UTF-8, because UTF-8 is a new character set that pretty much everybody defaults on these days, except a few random exceptions, which are still terrible. Yeah, UTF-8 is supposed to encode all these different characters. But yeah, the biggest difference, and it's also a big source of confusion, is UTF-8 is actually compatible with ASCII, which means that the first 128 characters are identical to ASCII. But then for any character beyond that, you need more than 1 byte, and people are not really used to that, especially the people from English-speaking countries, I think.
And to go further, we have to distinguish between the Unicode character mapping and the UTF-8 encoding, which is just an encoding to Unicode. And the ISO 8895-1 is the same, uses the same code points that Unicode uses for the second code page.
Yeah.
So it's also compatible to Unicode, not to UTF-8.
Yeah. But yeah, so that's also maybe that's also part of the confusion, because and especially the first, because the first 7 bits especially are identical. They're the same in ASCII, same in the European character sets, and they're same in Unicode. That means that as long as you stay within those bytes, you will actually not see any problems. But had UTF-8 been actually like a full-on break, it's like, let's start from scratch, not have any compatibility, then it also means that as soon as you make a character encoding mistake, everything would be completely crazy. Whereas now you won't actually see it right away, because if you just type HTML tags and stuff in most programming languages, you will just use those bytes, those first 7 bits, I guess, of every byte, and you might only see the problem later. And that's so it's both awesome that it is compatible, because most text will just work when you look at it in Unicode, and it wasn't Unicode originally, but it also is part of the problem.
True. So Unicode, you're saying we should use UTF-8 for everything and not worry about UTF-16 or UTF-32?
Yeah. Pretty much.
Yeah.
Yeah. I think a large amount of Windows API have settled on a variation of UTF-16. So I remember even some Windows versions that if you would actually save a new file in Notepad, it would actually save it as UTF-16, which caused some confusion for other people opening up again, because it would just look super weird. But UTF-16 uses by default not everywhere, but uses by default 2 bytes for every character, whereas UTF-8 always uses 1 byte for every character. But UTF-8 is pretty much... Sorry?
UTF-8 uses between 1 and 4 byte. Yeah.
Yes. Yeah. Sorry. Yeah. You're right. Yeah. So the lowest characters would always use 1, but it could be up to like a lot more bytes. And for 16, that's 2. But I think pretty much everybody universally has agreed on UTF-8 seems to be the sanest character encoding, and also some of the other ones have some other technical problems that make it hard to use. I actually read yesterday that UTF-8 came from it's kind of invented by the same guys who came up with an operating system called Plan 9. Which I won't go too deep into, but it's a kind of an experimental operating system coming from the same guys as Unix, and they wanted to build a better Unix. And if you look at the ideas they had, it's absolutely awesome, but it failed in practice. But UTF-8 was also came from these guys, and as they were thinking about it, it's
Cool.
pretty interesting.
Well, for me, the main point against UTF-16 and UTF-32 is, especially for European-related countries, those encodings always use 2 or 4 bytes for every character. So if you use mainly characters from the ASCII range, which could be interpreted using 1 byte, you always have 3 bytes garbage in the file, which blows up everything.
Yeah, it makes your files a lot bigger. Yeah.
Yeah. So when you use UTF-8, you have the advantage of small file sizes when you're using mostly the European or American character encodings, but you can show all the possibilities of the Unicode character set, and that's cool.
Yeah.
That's cool, and I'd really like to get into more detail later on, maybe in a different episode, about how Unicode works and the differences between UTF-8, 16, and 32, and talking about bits and bytes and character maps in those terms, because I get my head kind of just a little confused about all that stuff. But I was interested to hear Derek Rethans was originally in the talk about, or in the planning phases for this episode, but we weren't able to work out the schedule, and I just really needed to get this one kind of out because it's been like sitting there and I screwed up. This was supposed to happen earlier, my fault. I had a lot of things going on, but I would really like to talk to him about specifically in terms of PHP 6, which never became a full thing, but the main driving force behind PHP 6 was to actually add Unicode to PHP natively, from the engine to the extensions to the API, everywhere, so that it would just support UTF. Actually, I believe they were choosing to use UTF-16 instead of UTF-8, which caused some of the problems, and was one of the reasons why the project didn't actually wasn't so successful. I don't know. I could be wrong on that. Do you guys know specifics on that one?
I don't know a lot of specifics. I do actually remember that they first started with with UTF-16. It has some advantages over UTF-8 in certain edge cases, because especially if you assume you only use 2 bytes, then it's easier to just grab, say, if I want 5 characters from a Unicode string. Generally, with UTF-16, that's 10 bytes, except that's a big assumption, and that's often not true. So, and I think that's part of the problem. It's many years ago, so I don't know all the details. I also don't know exactly why that ended up failing PHP 6 as a whole. I think I got a feeling that it just became too much. It took too long, and it was just easier to continue the development of PHP 5 at the time. But yeah, it's unfortunate that he's not here, because he was like right in the middle of it, and he wrote us all of this stuff, and I'm sure he would have been able to give us some interesting anecdotes there. But yeah,
absolutely. Yeah. I'm going to try to sneak him in on another episode to maybe sneak that little bit in, just to see what happened. Maybe another internals talk. We'll talk about some PHP 6 and character encoding stuff.
Cool. But we have a little bit of leftover in PHP still from PHP 6.
Oh, yeah?
Yeah, a lot of people don't know that if you... I hope I say this correctly, because obviously I never use this, but if you specify a string in PHP, it's like you put whatever text in quotes, right? So if you, before the first opening quote, you can put a B, just the letter B, and that would kind of mark it as this is a binary string, this is not a Unicode string. So they actually added that to PHP 5, so it would be easier for people to eventually upgrade to PHP 6, but it's still in there. So you can actually just add a B to all your strings, and it doesn't do anything, but it's yeah, it's in there. Yeah.
A vestigial syntax.
Yeah. But maybe it's handy because so one of the things I thought about with PHP and Unicode is that it would have been so awesome to have, but at the same time, when I really think about my PHP code, most of the stuff I do, I actually do with strings, and sorry, I do with binary strings, and I don't necessarily need Unicode for a lot of stuff I do, and it's kind of nice to only have to opt into Unicode specific functions when I absolutely know I need this right now. Because, for instance, so one example is, say, if you want to get a position of a character in a string, you might think, oh, I use the str+ function for that, which is correct if you only deal with ASCII, but it's incorrect if you deal with Unicode, because Unicode might be multiple bytes, and it needs to. So there's an MB_string_pos function that does it specifically for strings and other character sets. Yeah, so I actually noticed recently. That a lot of the strings I pass back and forward are fine as binary, and not a lot of stuff doesn't need to be Unicode at all. And I'm sure we actually get some efficiencies because of that too. But it's also a big source of bugs.
Yeah, definitely. There is a setting in the PHP ini you can set. I'm not sure what it's called right now, which overloads your default string functions with the MB string functions.
Yeah, don't do this.
Can't do that. You can't. I just wanted to say you can do this,
Yeah.
but don't, because you should know what you're doing.
Yeah.
And then you're suddenly switching your host, and the setting is not set, and you get garbage and whatever.
Yeah. Now, I think it's a really dangerous function, but basically what that setting does is it switches all the default implementations of all these functions into the Unicode versions of that. But a big danger is that that works really well if you write your own PHP applications and you don't use anybody's code at all. You don't use Composer,
Exactly.
you don't use any other frameworks or libraries. But then as soon as you do, suddenly your whole PHP engine is doing stuff slightly differently. So if you string overloading and then you use a library that doesn't make that assumption, then suddenly a lot of stuff might break. And I've actually seen this myself. Like, I'm a library author myself, and I got completely weird bugs one day, and this is years ago actually, which caused me to realize that, okay, this is actually because they use string overloading or the string functions overloading. So I actually had to explicitly now say, on when you install it, this function must be turned off, and it usually is, like 99% of the cases.
Yeah.
But if you look at it and you read, what does this option do, and it sounds really like a good idea, it's not. Don't use it. Yeah, it's a bad idea.
But it implies that for all the string functions there is an MB string function.
Yeah.
So if you rely on character location in a string, use the MB string pos. It's the same parameters like the default string pos or whatever other string functions you're using.
Yeah.
And it makes everything very easy.
Yeah.
So if you're using anything less than PHP 7, you can use the MB string extension, so you can get like MB string pos and MB string length and all that stuff to deal with multi-byte strings. MB, that's what it stands for, multi-byte. So in 7, there were some cool things that came out with dealing with Unicode stuff, and one of those was the IntelChar, the INTLChar class. And you can do like IntelChar and statically call char, and then enter a code point, and it'll return the Unicode character for that. And I've been playing with that, and it does really well with emojis and everything.
Cool. Yeah, I think I've actually never used this, but I guess the Intel internationalization, I guess, must be what it stands for. I think it comes. I think that's the PHP version of the library that the UCI library, which is the library that the Unicode consortium creates, I guess. So just judging from the documentation, I guess you can get a lot of information about every single character. It doesn't replace the MB string functions, I think. I might be wrong there, but I think.
No, it doesn't.
Yeah. So, but I think
completely different set of
right.
Code.
But yeah, what you might be able to do with that is you might be able to throw a character at this thing and then have this
Yes.
thing tell you that, oh, this is supposed to be a white space in a certain language, because even there's a lot of different types of white spaces. So you can actually get more information about the intent of a certain character. Every different languages have different variations of like punctuation marks and other things that indicate something about how characters work together, how they should display together. So all this information about every character is part of the Unicode database, and using this library you can get information about specific characters and deduce maybe interesting stuff. Yeah.
Nice.
Is digit? I see. There's is upper, so you can find out if there's something is an uppercase character. Some languages have that, many don't. But yeah, so that kind of stuff.
That's cool.
Yeah.
Well, and Andrea Folds, I believe, was the one who added that, and then Colin Odell added the documentation for it. I remember we were talking about that at PHP Tech this past week, and that was really kind of cool to see that collaboration where he got to add the documentation. Now he's working on RFCs and getting more involved in internals and stuff. But Andrea also added something else that helps us with Unicode support in PHP 7, and that is the new Unicode code point escape syntax, which you can use within string literals.
Yes.
So I know, Everett, you already mentioned adding the B to your string literal. This actually adds a syntax within a string literal where you can do \u and then in curly brackets the hexadecimal code point of your Unicode character, and that also works well with emojis. Have you guys used that one yet in PHP 7?
No, I haven't.
No, I haven't used it yet either. Because there's certain situations where this would be extremely handy to use. For instance, say if you want to embed a white space from a completely different language that looks like a normal white space, then it's a good idea to do it as a Unicode code point, because that will actually document right in your source, okay, this character is special, and you probably don't want to just leave it with that. You want to add an actual PHP comment saying this is that character and this is why I did it this way. But I think in general I like to not try to avoid them if it makes sense. So for instance, if I have an umlaut that I need in my PHP sources, I prefer to just use the UTF-8 character, use the actual U umlaut character, because I also think it kind of works as like what's the right way to say it? Like a canary. Like when somebody else opens my file and they don't see that U umlaut right away, they see like I keep forgetting the term you use for it. Yes, exactly. Then they also, that's also an immediate indicator, oh, something is wrong with my editor settings. And I like to just assume that everybody can output Unicode everywhere. So I would only ever use those things for cases where it would be very non-obvious if you encode the actual character. Similarly, I think if I'm not mistaken, I think Greek and Turkish also has certain characters that look absolutely identical to the characters from our alphabet, but actually have different Unicode code points. So it would be completely non-obvious if you use one of those characters. So in those cases, I would always try to use it and document it really well. And I have a few weird edge cases like that, I think, in my unit test, but those still need to support PHP 5. So yeah, that's why I didn't use it there.
True that. Well, so taking it, so we've learned kind of some things that we can do in PHP to kind of help us with dealing with Unicode support. Outside of that, we also have to deal with these characters in HTML and also in the persistence layer like MySQL. So when it comes to HTML, how do you ensure that you've got the correct character map or character encoding rocking on in your HTML?
There's a very simple HTML meta tag now. I think it's new kind of in HTML5 where you can just say meta char set equals UTF-8. The interesting story there is that before that, in HTML4, you actually needed, that wasn't enough. It had to be a longer tag. I think it had to have the attribute HTTP equivalent or something like that.
Mm-hmm.
But as it turned out, most browsers didn't even look at that part of the tag. They just looked at char set. They just like scanned ahead, tried to find a string called char set as soon as possible. So the reason they just stripped it down in HTML5 was because it already worked that way in browsers anyway. So it's a very simple tag. that it's a good idea to embed it in your HTML, but even better is to also include it in your content type HTTP header, because this is the first line of defense. But you really need to have it in both places. Yeah.
Cool. And since HTML files, say for example, I'm dealing with just a plain text file, or even just a plain PHP text file, is it possible to save the plain text file as, say, ebcdic, and then try to send an HTTP header as UTF-8, and then put a meta tag for UTF-8, and then you've got like kind of this weird thing going on there?
I've never saved something in that character set.
I know that's from like the 80s or whatever, the 70s.
Yeah, it's like IBM mainframes and stuff, right? I suppose you can, but I think this is also part of the problem. You could actually specify the wrong character set, for whatever text you're using. And this actually was a major security problem in a lot of browsers at one point too. Because I think if you specify one character set and then in a different character set you specify again that it is actually a different character set, you would actually be able to manipulate the browser and kind of override what the actual character set was supposed to be. So this doesn't sound that weird yet, but the big thing was that I might be able as a user type this string in and say a 7-bit encoding or something like that, and it would be a perfectly HTML. It would be escaped for cross-site scripting and all that, but because I just use a certain amount of bytes in a certain order, I could actually trick the browser into thinking it was a different character set, and suddenly I have full control over the browser again.
Yeah, wow, that's crazy.
Yeah, but yeah, today
cool.
your lines of defense are use the content type header always, and always include a meta tag. And I believe you can also instruct the browser now to not do any sniffing and not make any weird decisions like that, but I'm not sure off the top of my head how you would do that. Yeah, but as long as you have those two, it's good.
Cool. And then just making sure that you're saving your raw text files, your raw PHP files, using your IDE as UTF-8, I guess, right? Just making sure that you're kind of UTF-8 all across the board. There was one, and you guys might be able to help me figure this out, because there was one particular issue, if I can remember correctly, where somebody was messing with an open source library, and they were having issues because they were saving it as UTF-8, but with an end of file character. Are you guys familiar with that? It was kind of screwing things up because. Yeah, maybe that's what it was.
The byte order marker.
Yeah, that sounds more familiar.
Yeah.
And there was like this big issue of whether they had that character and whether they didn't, and they were trying to save it like differently. Like, have you guys ever run into that?
Yes. Yeah.
Go ahead.
Okay. Yeah. So the byte order marker is so when the I don't know the exact history of events, but the idea was that, okay, so we have, the Unicode has these different encodings, right? There's UTF-8, there's UTF-16, there's two variations of UTF-16, LE and the other one, and the UTF-32. So, okay, right, yeah. So the idea was that, if you open a file, you don't know in advance what kind of character set this file is going to be. So you want to have some way to indicate this file is going to be in this character set. So when you send this file over HTTP, we have a really simple mechanism, which is the content type header. But when you just open a file from a file system, there's no indicator, there's no metadata from the file system that says, hey, this is this character set. So you can do some advanced use intelligence to figure out, oh, I'm seeing these bytes in these sequence, so it's very likely this is a string in English, so it might be UTF-8, and those detection systems exist, but they're not perfect. So the byte order marker was intended as a single code point, I think, or 2 code points that were the first 2 bytes of a text file, and those 2 first bytes would be encoded in whatever in UTF-8 or 16 or 32. So when you open the file, you see that first code point or those first sequence of bytes, and then you immediately know, okay, this is going to be in this character encoding. But the issue is that most systems that deal with files, like PHP fopen or stuff like that, they have no knowledge of this. So that means that whenever you open a file and it is a text file, you need to accommodate for the situation where there might be a byte order marker or not. So whenever you write a parser for an XML file or something like that, a lot of these things do support it, but if you do anything yourself, you need to consider that these 2 bytes might be there. And if you don't, then suddenly you have 2 random bytes at the start of something, and it might screw with your output. So yeah, it can have a lot of random side effects. I can give you an example right now of how that messed up my life once, but yeah, it's just something you need to consider when you open Unicode files.
Yeah, when you were saying that, it reminded me of the actual issue that they were having is that they kept getting this headers already sent
Right.
message in PHP, and he's like, "There's nothing above this line of
Yeah.
I'm starting at the
Yes,
the opening PHP tag right at the beginning. There's no space or anything, but he had a byte order mark there that was hidden to the IDE, and it was causing that character to be output in PHP, and then therefore couldn't set any headers."
Yeah. So your
Because
IDE should ideally already been configured to not save those. But IDE is also showing good behavior by not ever showing them because it's supposed to not show them and it's supposed to be ignored. But then when PHP wants to generate it, it actually just 2 bytes happen before the opening PHP tag, which means they automatically get echoed. But I was actually under the assumption that even the PHP engine, I thought, was aware of the byte order marker and would just not output them. But yeah, maybe I'm wrong then. Yeah.
I don't know what his environment was set up. It could have been like a really old version of PHP or something, or
Okay, maybe.
I can't remember.
Yeah.
I don't remember the exact situation, but
Fair
something
enough.
to look out for. If you ever get like something strange going on like that, just double check and see if you have a byte order mark at the beginning of your file. That
Yeah.
might be the issue. One last thing, so because we got to kind of start wrapping it up here. One last thing that where we have data stored in some sort of character encoding is the database layer or the persistence layer, whatever you're using. And I know for MySQL, I think the default still is every time you create a new database, as I'm pulling up SQL Pro right now, and I'm logging into my VM and I'm clicking Add Database, it's like,
You're
here's your
talking
default
about
Latin 1 encoding.
Is it? That's
Latin
crazy.
Swedish, yes.
Oh man.
Yikes. So I have to manually go in there and change this database encoding to UTF-8, UTF underscore general underscore CI. Case insensitive, I think is what CI means, right?
Please use the UTF-8 MB.
Yeah,
I think it's MB. Yeah, MB4. Oh yeah.
Oh, MB4.
Yes, because the UTF-8 tables in MySQL don't actually support the full range of UTF-8.
Yeah.
So to use the full range of UTF-8, please use UTF-8 MB4.
Oh my goodness, I've been doing it
multi-byte,
wrong.
4
Yes.
byte.
And you know why a lot of people are suddenly finding out that this is the correct thing to do is emoji, because emoji actually falls outside of the
Exactly.
range of what MySQL could normally store. So if you a few weeks ago tried to create a composer package and give it a description with a poo icon, then you wouldn't have been able to do that. But I think since then, Packages has updated this, and they're now switched to MB4 as well. But yeah, this is actually interesting, is because this has to do with how they store it. Because the original UTF-8 character set actually used 3 bytes to store every character. So when you as a user use MySQL, you get UTF-8, which is at least 1 byte and at most I think 6 now. But when you internally in MySQL will output it in that way for you. However, for every character you store, it will still use 3 bytes internally because it's much more fast to do operations like that. But those 3 bytes is at most 3 bytes, so it just didn't fit every single character. So the fix of MB4 actually means that from that point forward, MySQL will use 4 bytes for every character, which will actually support emoji. But it's interesting because if you store the string hello in MySQL MB4 encoded table, then it will, let's see, it's 5, so it will actually at least be 20 bytes plus whatever extra overhead there is. So this is also something to consider. Is like some of your fields might not actually have to have that full range of Unicode. So one thing I actually do is I really think about, okay, is this real text that a user enters that they might want to put a poo icon in? Then yes, it's text or it's varchar or something like that. But if it's a different field, for instance, an email address or a URI, or for instance, something that ends up in a URL like a username or something like that, in a lot of cases you actually explicitly only want to support ASCII because it looks nice everywhere and it's predictable. So for those cases, you don't have to do that. And actually myself, I use var binary or blob for those, depending on how much space I need, because it's a really big saver. But it does actually, it removes some of the features. You can't easily search within the strings and all that stuff. But I find for a lot of identifiers, this is actually good enough, and it actually makes my MySQL database a lot faster. But yeah, usually your default should probably be varchar and text and UTF-8 and B4.
Wow. So how trivial is it to convert a database that I've already got it set up in UTF-8 to UTF-8 MB4?
Not trivial, I think.
Uh,
Yeah, it's been a while since I've done it, but you know, I think one of the other issues there is that I think a lot of people who made that mistake, it's not a matter of, sorry, did you ask where to go from UTF-8 to UTF-8 MB4? Because that's easy, but to go from
That should be easy.
yeah, but from Latin
Because
1.
you have lost the information already.
Yeah, exactly. Yeah, so that's easy, but I think going from Latin 1 to UTF-8 is really hard.
Oh yes.
Yeah. So I don't know if I forgot which question you asked, but like if you want to do that and you just accepted whatever my SQL defaults were, it's going to be a lot of trouble. And not so much because you can easily convert a Latin 1 string to a UTF-8 string, but that's not the problem. The problem is that a lot of people set their database as Latin 1, but then still send UTF-8 bytes to your database. And MySQL won't actually do any validation. You just accept any byte just easily. Yeah, so now your problem is not just, okay, I need to convert from one thing to another, but you also need to figure out exactly what you stored. So I guess, one general advice I would want to give everyone is that for when it comes to character encoding is not only make sure that everything in your stack is configured as UTF-8, so HTML, MySQL, PHP, but also whatever external input you get, you actually need to not just assume it's UTF-8 or convert to UTF-8, actually figure out what encoding is what are they sending me, and then do the appropriate encoding immediately as soon as it enters your PHP database. Because you might have an API and somebody might be consuming that API, and that whoever consumes that didn't think about this. So you need to always think about it, convert everything, reject strings that aren't properly UTF-8, and that is the only correct way to deal with this. Is to think about all your different inputs and think about all the character encodings of those different inputs, and just make sure everything becomes UTF-8.
So if I have a website set up and it's got the meta tag UTF-8 encoding charset, it's got the header UTF-8 HTTP header. If I have a form on there and they start typing in whatever characters, emojis, and everything like that, is that going to be sent to the server as UTF-8 because I've defined that in the document, or does it get set as whatever their locale is on, or whatever the character encoding they have set on their computer?
I think there are some edge cases where it will not take the character encoding of your document, but you actually also, even the form tag has a character set attribute, or I think it's enc type or something like that. But I think these days modern browsers do this correctly, but I know at least back in the day you also need to explicitly specify in the form what character set am I sending this in. Yeah, so it's not even as simple as that. You should validate it. That's really the core advice here. Is that you're getting strings from a user, you need to validate.
It's user input validated.
Yeah, exactly. Yeah, is this valid? Because even if you set all those settings correctly, that still means I can send you a null character, I can send you a tab character or a bell character, and the naive PHP application will just accept that character and store it in a database, and it's wrong because it will mess up your stuff. And so validate it. Yeah.
So there could be a situation where everything in my code base and everything is set up to UTF-8, it's running beautifully, but in my persistence layer I've got Latin 1. So when I accept these UTF-8 code points, it gets actually stored in the database as Latin 1 code points, which are totally different characters. But when I read it back out, it reads it back as UTF-8 code characters. Code points, and it reads just perfectly. So I think everything's fine, right? Until I take that database and try to do something else with it, and suddenly, as I export it to another system or something like that, suddenly I get all these weird characters. Well, it worked on my system originally. What happened? I guess that's a common problem that people will fall into, right?
Yeah, absolutely.
I bet you didn't set names.
Yeah.
The thing is, especially in MySQL, the client. So the PHP has a character encoding which is set to UTF-8, and the database and the server have a character encoding which is set to UTF-8. So everything's fine, you should think. But the connection between the client and the server has a character encoding as well. So when you forget to set the character encoding of this connection to UTF-8, what happens is you put in a UTF-8 character, which contains 2 bytes. So the connection takes those 2 bytes, but it thinks, oh yeah, thank you very much, I got ISO 8859, and then it gives those 2 bytes to the database, and the database itself then says, oh, thank you very much for those 2 ISO bytes, so I have to convert them to UTF-8, and now you have 4 bytes, and you have a lot of garbage in your database.
Yeah.
So the main thing you should do is, as soon as you open a connection to the MySQL server, set a SQL command, set names UTF-8, and then the connection is set to UTF-8.
Yeah.
So I guess the moral of the story is don't use MySQL, right? I'm just kidding.
I didn't say that.
No, I do know that other databases have we'll call them better defaults, but something to still consider and not rely on defaults as a good programmer, I suppose, would be to actually make everything explicit, right? No matter what database you're using.
Yeah.
Yes.
For sure.
For sure. All right, cool. Well, this has been really eye-opening. I thought I had character encoding figured out, and no, I don't. I still have lots to learn on this, and I'm excited to kind of ask some more questions, especially when it comes to PHP 6 stuff, and then try to figure out if my database stuff is screwed up now, especially since I'm not using the MB4. I mean, why make it so confusing? Well, whatever. That's the plight of computer programming, I guess. Yep. If you guys have never heard of this thing called GitHub, you should check it out. It's this great place for open source contributions, and it's a great place to learn more as a programmer and become better at your day job or your hobby, whatever PHP or programming is to you. And if you go to github.com/PHP Roundtable, you'll see this repo sitting there called the Show Notes repo. And it's a great place that you can contribute show notes to this phproundtable.com. So you just listen to an episode, and while you're listening, just sit there and write some notes and mark down, and then submit a pull request to PHP Roundtable Show Notes repo, and I'll give you total credit. I'll give you a shout out and be like, so and so gave the show notes for this episode. Thanks so much. So definitely check that out. I'd love to hear you guys. Or I'd love to get contributions from you guys, and you totally get credit for it. Speaking of contributions and being an awesome developer, every episode I like to wrap up with this thing called the Developer Shoutout, and it is where we recognize somebody in the community for doing something awesome, and we do that by sending them a $50 Amazon gift card and a handwritten thank you note and a nice little PHP Roundtable sticker that's huge. And for the $50 Amazon gift card, the sponsor, the long-time running sponsor, is Laracast.com, and if you've never heard of them, they're basically this the de facto learning source for everything Laravel, but also everything kind of testing and IDEs and workflow and developer anything. Jeffrey Wace is the guy who does all these screencasts, and it's really great. He just takes you step by step how to do these, doing things that you've never even heard of before, and then suddenly you're an expert after you watch these episodes. So definitely check out Laracast.com. Thank you, Laracast, for sponsoring the Developer Shoutout for so long. And for this episode, we nominated somebody for the Developer Shoutout who happens to be one of the PHP Fig secretaries, who are currently in the very difficult job of herding kittens, as been affectionately named for their job, and we could reward this to any one of the three, but today we are awarding this to Michael Cullum. So, Everett, why did we choose Michael for the Developer Shoutout for this episode?
Well, Michael has spent a lot of time to work on PHP Fig 3.0, which is a very, I'm sure, humbling task. I think in general, I also find Michael to be a very humble and listening person that doesn't let his ego get in the way of progress. So I just, he has a good style, and I think we need more people like him to advance PHP in the PHP community. That's why.
Awesome. Well, thanks, Michael, for your excellent kitten herding abilities. Herding, not hurting. Hurting. That would be so weird. So I will be reaching out to you to get your snail mail address and send this gift card to you and a handwritten thank you note. And I think that just about wraps us up here. I always like to wrap it up with officially a shameless plug from you guys. So, Andreas, do you have anything that you want to shamelessly promote?
Yeah, of course, php.ug. If you don't know where the next user group is where you can learn such informal stuff, just head over to php.ug. If you are running a user group or a member of a user group and it's not on php.ug, feel free to drop us a line or promote the user group on the website so that we can find more user groups worldwide.
It's a great resource. Thank you so much for doing that. And I think of you as the Cal Evans of Germany.
Oh no! That's definitely Michelangelo van Damme.
Oh yeah, but he's not in Germany though, right? He's in.
No. Okay, from Germany. Okay, I can get that. Yes.
What about you, Everett? You got anything you want to promote?
Yeah, if you have a PHP application and you do stuff with uploads or managing users' assets, something like that, take a look at my project. It's called SaberDev. It's a library, and if you implement this library, it's supposed to work with a lot of frameworks, and you can basically get PHP into your file system. And suddenly you can mount your PHP application and just drag and drop files from your computer to your PHP application mount. So it's pretty cool. It's easy to use. Take a look.
Very cool. Well, this has been a super awesome topic that is kind of opening my mind to some other future topics we could talk about. Also, we're going to be pretty soon talking about HTTP2, which is kind of the new HTTP layer that's coming out, or new specification that a lot of websites are already rocking on. So if you want to learn more about that, we've got a great panel for that. We're also going to be talking about Docker and PHP, which might be interesting. Yes, cool. And some other topics are about event sourcing and some cool things that we just sort of in the works, but haven't really nailed down any specific times. But those are all coming down the pipe soon. If you have something that you'd like to share about on the PHP Roundtable, some kind of PHP-ish topic, it doesn't have to be specifically PHP like today's topic wasn't specifically PHP, but it certainly relates to us developers. Hit me up on Twitter, I'm Sammy K, or go to phproundtable.com and fill out the form that says, hey, I got this topic idea, or hey, I'd like to join the roundtable because I'd love to have you listening. If you're listening in your car and you're like, I could talk more about this topic, then just as soon as you stop driving, don't do this while you're driving, but stop driving, and then type in phproundtable.com and then fill out that form. I'd love to have you on the panel. Andreas and Everett, thank you so much for joining us for this topic discussion.
Thank you.
And we'll see you.
Thank you.
Yeah, absolutely. We'll see you guys in the next episode.
Sounds good. Bye-bye.
Cool. Bye.
Bye.